Hey, welcome together to learn something about testing power quality analyzers. To start with, first of all, a little bit of introduction and background knowledge. As you all know, in the electrical grid, a sinusoidal oscillation is wanted by the consumers and also by the grid operators. But in reality, this sinusoidal waveform is not given, but we have some kind of a disordered waveform which differs from this ideal waveform. Now, this is important. Power quality is or wants to measure or to quantify the degree of conformity between the ideal waveform, which is sinusoidal, and the real disordered waveform in the grid. Therefore, there are several power quality criteria defined, and of course, first of all, there's the frequency, then we have the magnitude of the voltage and current, we have flicker, which are short-term voltage fluctuations, then we have long-term voltage fluctuations like dips or swells of the voltage, and we even have interruptions. Of course, there are transient voltages and very fast, rapid voltage changes. Then there's voltage or current unbalance, and of course, as you all know, there are harmonics and interharmonics. But what are the effects of insufficient power quality? Why is power quality important? I think first of all, there are less severe effects like noise, overheating, or increased losses. But then there are even fatal effects like breakdown of assets, like reduction of the asset lifetime or power failures. And we can continue this list. There are communication interferences, there's the need for oversizing the grid because of increased losses, and so on and so forth. But when we come to the point, all of these effects end up in one thing, and this is money. So bad power quality costs a lot of money. And we can also have relative or absolute values for these financial costs. For example, very sensitive industry sectors already have costs for power quality about 4% of their yearly turnover, which is a lot, I think. Or even when we have an absolute number, the European Union spends up to 150 billion euro per year for insufficient power quality. Let's have a look on the single stakeholders which can have an interest on testing their power quality instruments. First of all, of course, the manufacturer which wants to promote a new product, he has to certify his new power quality instrument according to a type test which is defined in the IEC 61430. Then there is the industry concern. He does not want to lose money for a power quality problem which may have an insignificant impact but which is not detected because he has no functioning power quality instruments in use. Then the energy consultant, which wants to analyze and optimize the energy consumption of his customers. He of course is dependent of full functioning and so tested power quality instruments. Then there are utilities which simply have to prove conformity with several power quality criteria which can be seen in the standards 5160 or also in the international standard which is available. Then there are grid operators which may want to buy a high number or a big number of power quality instruments for their whole grid. And first of all, they will do some kind of an acceptance test to be sure that they choose the right power quality instrument from the right manufacturer which meets all of their needs. Last but not least, of course, there are the energy consumers. They want to have a stable, a safe, and of course, cost-effective energy supply. And this can also be supported with tested power quality instruments. So, coming to the relevant standards which are valid for power quality testing. First of all, and most important, there's the IEC 61430, which is the most important standard when it comes to requirements to the power quality instruments, and also defines the accuracy requirements and the classification into class A, which is very accurate, or class S, which is a little bit less accurate. Then this standard points out to the standards IEC 62586-1 and -2, and there especially the -2 is very important when it really comes to testing of power quality analyzers, because within this standard there are the real test signals, there are test conditions and test points defined which have to be injected when you do a power quality test. There are also some extra standards which are for special criteria like flicker or harmonics and interharmonics. All of these standards are just related to the power quality instrument, so they are on the product side. On the other side, from point of view of the grid operators, we have a standard that defines power quality criteria that have to be met for the power that is supplied from the grid. And this is, like you can see on the right side, for the European area, it is the EN 50160, but there are also international standards available. When we have a deeper look into the functional tests, which are defined in the IEC 62586-2, the most important chapter, I think, is chapter 6, because there are all of the functional tests mentioned. And this chapter 6 has several subchapters. All in all, there are 17 subchapters to have tests for every single power quality criteria. For example, when we have a look on the magnitude of supply voltage tests, there are also, again, several subchapters, and it's most of the times there are 3 subchapters for each criteria. The first subchapter is checking for several measurement methods. The second subchapter is checking the measurement uncertainty over the full measuring range. And then in the third chapter there are several tests for the aggregation of measurements. All in all, there are 17 test criteria and more than 250 test signals.